Okay, this is Dr. Williamson, and this is homework problem 18.33. And a lot of students have asked me how to do this problem. And so I figure I'll go ahead and do a YouTube video for this. Okay. So first off, this says, how many moles of hydronium hydroxide must you add to 5.6 liters of a strong acid solution to adjust its pH from 4.52 to 5.25? Assume a negligible volume change. Well, we're going from 4.52 to 5.25. That means we're going in a basic direction. We're in a base direction. So we'll be adding hydroxide. But we're going to be adding hydroxide to consume hydronium. Let's see how much hydronium we have to consume. So the concentration of hydronium ion, I'm just going to write H plus. At 4.52 will be 10 to the minus 4.52, and that will be equal to, this would be easier if I text. So let's go 10, 4.52 negative. That'll be 3.02. Let's go some extra sig figs on this. 3.01995 times 10 to the negative fifth molarity. I went too many sig figs on this because whenever we do log or anti-log, I'm cheating for a reason. All right. So let's find the hydronium ion concentration, or the H plus concentration. That's hydrogen ion, but I'm writing with my mouse, not a stylus, so it's just easier to write this. 10 to the negative 5.25 will be equal to, okay, so 5.25, 10 to the negative that'll be 5.6234. 1, 2, 3, 4, 6, 2, 3, 4, 1 times 10 to the negative 6 molarity. Okay. Now to find the moles of hydrogen ion in each one, I'm going to multiply each by 5.6 liters. So I'm going to go 5.6 liters times this. 5.6 liters times this. So it'll be times 5.6 liters. 5.6 liters, because remember, this is moles per liter there, okay? Molarity is moles per liter, okay? So I'm going to do the bottom one times 5.6 liters. This one will give me, here, I'll kind of do it on the bottom underneath, 3.149 times 10 to the negative 5 moles of H3O plus. Okay. And then this one will be equal to, so 1, 2, 6, 1.691 times 10 to the negative 4 moles of H3O plus. Now, if I take the difference between those, delta moles of H3O plus, if I take the difference between those, okay, that was sloppily written, H3O plus. Because remember, H plus and H3O plus are synonyms for each other. Okay, I'm going to subtract these two. Minus 3.149. All right. Where's that? E to the negative 5. If I did it right, I get 1.376 times 10 to the negative 4 moles, or within the correct sig figs now, 1.4 moles of H3O plus that has to be consumed because I'm going in the basic direction. So I'm having to add excuse me, not 1.4 moles, excuse me, 1.4. Hold on here, I'm just messing all up today. Okay, I'm having to add here 1.4 times 10 to the negative 4. We're going to add, let me just 1.4 times 10 to the negative 4 moles of OH minus to consume 1.4 times 10 to the negative 4 moles of H3O plus. Okay. According to the reaction, H3O plus OH minus gives 2H2O. Okay, I kind of meandered and walked and talked my way through that. Not the best lecture teaching, but I'm solving the problem for you guys. So I hope that helps. I went to more sig figs than I normally would do. Right over here. And right over here. Because when I'm doing anti-logs, sometimes it's better to go to more sig figs than you normally would do, and then you hide it from your professor after the fact. Okay. So I hope that helps, and you guys let me know if you need any more help. I'd be happy to help.